So E and F are events, and we know a few things about their probabilities. We need to determine the probability of F given E and of F given E complement. Alright, so let's write those down and apply the conditional probability formula for both of them. So, the first thing that we need to do is we need to figure out the probability of F given E. And by the conditional probability formula, that's exactly the probability of F intersect E divided by the probability of E. And it turns out that we actually know one of those. It's given to us that the probability of E is 1/12. So this is something divided by 1/12. All right, let's do the same thing now for the probability of F given E complement. So using the conditional probability formula, we get that that's the probability of F intersect E complement divided by the probability of E complement. And now, since probability of E is 1/12, the probability of E complement is 1 minus 1/12, which is 11/12. Alright, so now we need to figure out the numerators. And to do that, we're going to have to use this other piece of information right here. We know that the probability of E given F is 1/3. So let's work with that. So the probability of E given F, remember, that's the probability of E intersect F divided by the probability of F, and we know that that is 1/3. Okay, we also know that the probability of F is 1 minus 3/4, or 1/4. So the probability of E intersect F divided by 1/4 is equal to 1/3. And now we can multiply both sides by 1/4, and we see that the probability of E intersect F is 1/12. And now we have enough information to make a Venn diagram. Alright, so here's our sample space. We have E and we have F. And we can start filling this from the inside out. So we know that the probability of E intersect F is 1/12. Further, we know that the probability of E, the entire circle that represents the set E, is 1/12. And all of it's right there, so that means the probability of this part is 0. Then we know that the probability of F complement is 3/4, which means that the probability of F is 1/4. So in this whole circle that represents F, we need to have 1/4. So if you do the subtraction, 1/4 minus 1/12, you'll get 2/12 over here. And then finally, we know that the entire Venn diagram, the probabilities have to add up to 1, so the area outside has to be 9/12. Alright, so we filled in our Venn diagram, and now we can figure out the remaining probabilities to figure out the conditional probabilities that we wanted. So, the top one, all we need is the probability of F intersect E. F intersect E and E intersect F are the same thing. Both of those are 1/12. So this is 1/12 over 1/12, which is 1. So that tells me that if I know E happened, then F had to happen. And that makes sense. If you look at this picture, all of the probability of E is actually within F. So really the event E is inside of the event F. Alright, then for the second one, in the numerator, we need the probability of F intersect E complement. So that's the probability of being in F and outside of E, and that's this part right here, that's 2/12. And so this reduces to 2/11.